Hello and welcome to Bedroom Physics. There are few events in an individual's lifetime that will radically change them. For Alfred Nobel, it was when his premature obituary came out and stated that the merchant of death is dead, and it prompted him to create a prize to celebrate humanity, the Nobel Prize. For me, it was physics, electricity, and magnetism. That class instilled great vigor and tenacity within me in respect to physics. And so today is a very special lecture because this chapter is the first chapter that we learn in electricity and magnetism. However, this video will only be an introduction to electrostatics, and there will be follow-up videos on electric fields, Coulomb's law, and dipoles. Without further ado, let's jump into electrostatics. There are two types of charges: positive charges and negative charges. The proton holds the positive charge while the electron holds the negative charge. Two protons will repel each other, two electrons will repel each other, and a proton and an electron will attract each other. Protons and electrons make up the atom along with neutrons. While an electron is an elementary particle, protons and neutrons are made of quarks. But that's not important right now. If we look at the lithium atom, we will see that within the nucleus there are 3 protons, and this nucleus typically spans 10 to the negative 15 meters. And from the nucleus, electrons can go as far as 10 to the negative 10 meters. This is the typical volume of an atom. Now, the charge of an electron, or specifically the magnitude of the charge of an electron, is exactly equal to the magnitude of the charge of the proton. And so, if an atom has less electrons than there are protons, then it'll be a positive ion, meaning that the atom will have a positive charge. If there are more electrons than there are protons, then it will be negatively charged and it will be known as a negative ion. The process of atoms losing or gaining electrons is known as ionization. The masses of electrons, protons, and neutrons are 9.11 times 10 to the negative 31 kilograms and 1.7 times 10 to the negative 27 kilograms, respectively. There are two important principles in respect to charge interactions. The principle of conservation of charge, which states that the algebraic sum of the electric charges in any closed system is constant. For example, if I have a neutrally charged object and a second one, if I touch them together and one becomes negatively charged and the other becomes positively charged with the same magnitude as a negatively charged object, there have been no charges which have left the system or entered the system. Rather, the charges transferred from one object to the other. If electrons transferred from one object to the other, then one of them will be positively charged and the other negatively charged if they started both neutrally charged. The second principle is that the magnitude of charge of the electron or proton is a natural unit of charge. In other words, that the charges are quantized, meaning that any amount of charge within an object or on an object is an integer multiple of the natural charge, the charge of the electron, for example, or the charge of the proton. But didn't I just say that protons and neutrons are made up of quarks? Well, yes, but quarks can't be observed in isolation. In the realm of electricity, there are two important materials which are conductors and materials which are insulators. Conductors permit free movement of charges while insulators do not, which leads to something called charging by induction. If you get a charged rod and then a conducting object of some sort, in this case a ball, which is being held up by an insulator sitting on ground, or basically ground is just the earth. It's a big electron sink. If you move the charged object close to the ball, then the opposite charge within the ball will move closer to the object, while the same charge will move farther away from the object. Now, if you took a wire, once these have been organized as such, we can get rid of this excess charge or induced charge by attaching a wire to the ground. Now, the ball is positively charged because we used a negatively charged rod, in this case, to organize its charges as such. So basically, we've attracted one set of charges to one side of the ball while the other was repelled, and then we got rid of the repelled one by attracting it to, in this case, an electron sink known as ground. This is called induction. Now, this specific event of organizing positive charge on one side and negative charge on the other is known as polarization. Even within insulators, even though they don't permit for free travel of charges, the charges can still shift within the insulator. So if we had an insulator and then we took a charged rod and put it next to it, the electrons within the atoms of the insulators will attract or be attracted by the positively charged rod and will align themselves in order to get closer to the positively charged rod, while as a consequence the protons will be aligned the other direction. The same thing will happen vice versa if the rod was negatively charged. Now, in the second video I will start talking about Coulomb's law, but for now, an introduction. This is Charles Augustin de Coulomb. He was born in 1736 and died in 1806, and he studied the interactions of charged forces within his lifetime. And he discovered, using something called a torsion balance, that when the distance between attractive charges were doubled, then the interaction force between them will be quartered, that is divided by 4. However, when the distance was half, then it was scaled by 4. And this discovery will set in motion what is now known as Coulomb's law. In any case, this has been the introduction to electrostatics. I hope to see you in the next concept video.